In this video, we're going to investigate the one reaction that ethers can undergo. Ethers have electrophilic carbons and a nucleophilic oxygen, but they're rather unreactive. Although there are two electrophilic carbons, there's not a good leaving group if they were to be attacked by a nucleophile. And if you want to try to protonate to make a good leaving group, you have to use a very strong, very concentrated acid, and that's actually the strategy that's used for the one reaction that we will learn. And they also have this nucleophilic oxygen, but here's what happens whenever an ether, say, attacks something like an alkyl halide. You end up forming this positively charged oxygen, which is not stable. And that's a different situation than when we had the alcohol, because the alcohols have a proton that can be removed, so you can just deprotonate and get your neutral oxygen back. But an ether doesn't have a proton to remove, and so it's kind of stuck like this. And having that unstable product is not going to be favorable, so the reaction equilibrium is going to lie far to the left. But there is one reaction that ethers can undergo that we will take a look at, and that is reacting it with two equivalents of hydroiodic acid to yield two equivalents of the alkyl iodide, as well as a mole of water. The ether can be protonated in concentrated HI, and this is similar to the reaction mechanism that you saw for protonating the alcohol, so you end up with this nice leaving group here. And you also have I-, which is a good nucleophile. So I- is going to come over and attack the one of the electrophilic carbons, and the other side is going to leave as a leaving group. So after this first round, we have one equivalent of Ri and one equivalent of an alcohol. But we now have an alcohol in the presence of HI, so it's going to do what alcohols do and get protonated. And now we're going to have the protonated alcohol species with a good leaving group on it. And we have I- that can come in either through an SN1 or SN2 mechanism, depending on the identity of this R group. But we'll end up getting a second equivalent of Ri, and then the water, that was the leaving group.